Okay, let's unpack this. We've got these sources here all focused on money, how it grows, specifically interest. Our mission in this deep dive is to cut through the formulas and details and really show you the core ideas. Simple interest versus compound interest. We'll use the examples provided.
Exactly. We're boiling it down, taking the definitions, the examples, and showing what matters, how interest works, and maybe more importantly, the difference it makes how it's calculated.
Right. So let's start with the building blocks laid out in the material. You've got the initial cash, the principal.
The money borrowed or lent.
Then there's the cost of using it, the interest.
Yep.
That's usually shown as a rate, like a percentage per year, right?
Right.
And it applies over a certain time.
Correct duration.
Add that interest back to the principal, and you get the final amount. Seems simple enough on the surface.
And that basic structure works for both types, simple and compound.
Mm-hmm.
But the real difference, the crucial bit, is how that interest gets calculated over the time period.
Okay, so that brings us to simple interest first. What's the main idea here?
Well, the sources are pretty clear on this. Simple interest is only ever calculated on the original principal. That's the key. The interest you earn, or maybe owe, it doesn't get added back to the principal for the next calculation. It's just a flat rate on that starting amount over time.
Okay. And the material gives us a formula, like a tool for this. I equals P times R times T over 100.
That's the one.
And there's that example, calculating interest on, was it 1,300? For a kind of specific short time, late December 2002 to mid-May 2003, at 7.5% per year.
Yeah, that example's good because it shows something specific. When you've got odd periods like that, you have to count the days carefully. The sources say exclude the start date, include the end date. For that specific loan, it works out to exactly 146 days.
Right, 146 days. And because the rate is per year, you can't just plug in 146. You have to convert it, make it a fraction of a year. So 146 over 365.
Exactly. You plug all that into the formula like they show.
And the interest comes out to just 39 euros. Well, it shows that even with a decent rate, simple interest over just a few months can be a pretty small number.
And the material also points out, if you know the interest amount, you can flip that formula around to figure out the original principal or the rate or the time. It works backwards too.
Okay, makes sense. But now, this is where it gets really interesting, I think. Let's talk compound interest.
Ah, yes. The interest on interest idea, this is fundamentally different. As the sources explain, the interest earned in one period gets added to the principal. So that new, bigger amount becomes the principal for the next period.
So hang on. With simple interest, the principal amount stays the same the whole time.
Correct.
But with compound interest, the principal itself actually grows.
Precisely. Period after period. The actual compound interest paid or earned is just the final amount minus what you started with, the original principal. And there's a clear example in the sources for this too. Calculating compound interest on $6,000 for 2 years at 10% per year. So for year one, it's simple enough. 10% of your $6,000 is $600.
Right.
But, and here's the key difference, that $600 interest gets added to the $6,000 principal.
Ah, okay. So going into year two, you're not calculating interest on $6,000 anymore. You're calculating it on $6,600.
You got it. So 10% of your $6,600 is $660. See? The interest earned in the second year is more than the first year.
Yeah, 60 more.
So the total compound interest over the 2 years is 600 plus 660, which is 1,260.
Okay, wait. If that same euro 6,000 had just earned simple interest for those 2 years at 10%, that would be 600 each year, right? So 1,200 total.
Exactly. 1,200 simple interest versus 1,260 compound interest.
So that extra 60 is purely because the interest from the first year started earning its own interest in the second year. That's the compounding effect.
That's it, precisely. And the sources lay out this comparison. Simple interest gives you the same fixed interest amount each period. Compound interest gives you a growing interest amount each period because the principal it's calculated on keeps increasing. The material even mentions, this works even if the interest rate changes year to year.
To really hammer the point home, there's that other calculation they showed directly comparing the difference on 10,000 at 5% for 2 years. Simple interest is 1,000, but compound interest is 1,025.
A difference of 25. It sounds small, maybe, over just 2 years on that amount.
Yeah, but it shows the principle perfectly.
It does. That extra 25 only exists because the 500 interest earned in year one started earning its own 5% interest in year two.
So what's the bottom line here? We've looked at the mechanics. Simple interest is, well, simpler, calculated only on the starting amount.
Right.
Compound interest builds on itself. The interest gets added back, making the principal grow, which means future interest calculations are on a bigger base.
Leading to faster growth over time.
This dive into the sources really shows how that one change, letting the interest compound, makes a difference, even in just a couple of years.
Yeah, and it does raise a bigger question, doesn't it? If compounding makes that Euro 25 difference over just 2 years on 10,000 time, what could that interest on interest effect look like over, say, decades? With savings or maybe investments, imagine that difference scaled up over a much longer time. Something for you to think about definitely as you navigate your own finances.